So we're starting with the very last lecture of the course, and normally we will try to cover sections 8.1, 8.2, and 8.3 of Chapter 8, but we're only going to cover a little bit. We're not going to cover anything in Chapter 8.3, and of 8.1 we're just going to cover what's known as the square root property. 8.2, we're going to learn how to complete the square and use that to solve quadratic equations of the form x squared plus bx plus c is equal to 0. Notice that the x squared, the coefficient is 1. And then finally, we're going to introduce you to the quadratic equation as a general method for solving equations of the form ax squared plus bx plus c equals 0, where we cannot factor the left-hand side. And we always want you to factor if you can. It's usually faster and easier. But when ax squared plus bx plus c is prime, factorization is not an option, but we can still find solutions. And then the last thing I'm going to touch on is the discriminant. All of these are going to be really basic, and I'm pretty sure they're simple enough that I'm justified in giving you one last miniature exam on the topics we discover, or we cover rather, with the hope that you'll get a high score because they will be really basic and not involved. And I think everyone in the class could use one exam with a high score. So, let's start. So the first thing I'm going to introduce you to is what's known as the square root property. Sorry, I just ate some peanuts, so you may see me drink some water. Now hopefully that'll be it. I don't know why I ate peanuts before I did this. Anyway, square root property. If b is a real number, so that's what's important, if b is a real number, and a squared is equal to b, then a is a square root of b, and hence a is equal to plus or minus the square root of b. So we're going to use the square root property to solve x squared is equal to 50. Let me readjust. And as always, this one is it's pretty simple, so I actually want to derive it. So I'm going to derive the property using this example. So this is example 1. So we have x squared is equal to 50. And the way we always solve these problems is we put them into the general form of ax squared plus bx plus c is equal to 0. So I need this to be in that form. So I have to move the 50 over. So I get x squared minus 50 is equal to 0. And now I'm going to simply note that we've learned that the square root of 50 squared is actually equal to 50. So I can rewrite that as x squared minus the square root of 50 squared is equal to 0. And recall, a squared minus b squared is equal to a minus b times a plus b. So here, clearly, my a, let's write the formula underneath there, minus b squared is equal to 0. My a is my x, and my b is the square root of 50. So this gives me a factorization. X minus the square root of 50, x plus the square root of 50, and that is equal to 0. And we fall back on our old zero product law. That implies x minus the square root of 50 is equal to 0, or x plus the square root of 50 is equal to 0. So that tells us x is equal to the square root of 50, or x is equal to minus the square root of 50. And many times we will write that as shorthand as saying x is equal to plus or minus, that's what that symbol stands for, the square root of 50. And indeed, that's what the square root property says. If b squared is equal to a, and a is a real number greater than or equal to 0, then b is equal to plus or minus the square root of a. And by doing it this way here, it clearly shows why we need both a plus. We don't write it here, but if I want to right now, that's the positive root, this one's the negative root, this combines both of them. So using that property, we could have immediately, I'll write it right here over line on the side, we were asked to solve x squared is equal to 50. So we could immediately employ the square root property. 50 is greater than 0, so that tells me x is equal to plus or minus the square root of 50. And we get to the exact same end result, but with much fewer steps. And that's always nice. Once we have a theorem, then let's use those steps. So let's use the square root property to solve 2x squared minus 14. So in this case, we're actually going to do the opposite of our intuitions. There's two ways to do it. I'm going to do it both ways. So the most mathematical way, you might say, and I even hate saying that because they're all fine, is to notice that this has a common factor. And 2x squared and minus 14 has a common factor of 2. So I pull out the 2. That's x squared minus 7 is equal to 0. But I can divide both sides through by 2. When I divide both sides through by 2 on the left-hand side, I get x squared minus 7. 0 divided by 2 is equal to 0. And now I can use the square root property by doing what we don't normally do. I'm going to take the minus 7 and put it over there, and it can become plus 7. That's squared. So by using the square root property, x is equal to plus or minus the square root of 7. That's one way to do it. Perhaps the more direct way to do it, the one that is really almost the no-brainer, is to do it this way. Just simply start with 2, I need to make that larger, 2x squared minus 14 is equal to 0, and move the 14 over. That will give me 2x squared is equal to 14. Now divide both sides through by 2. That gives me x squared is equal to 7. And using the square root of property immediately, I get x is equal plus or minus the square root of 7. The only thing I want to make clear here is the reason we were able to use this property is because 7 is greater than or equal to 0. And finally, our last example. So all of these are really basic, and I'm hoping you're saying, yeah, I can do this, because there really isn't much to it, and that's the reason I'm thinking about actually doing what would normally be something that you would resist. But since this does seem to be so basic, giving you an exam on just this material should help your grade rather than hurt it. At any rate, this material will be also on the cumulative final. So here's number 3. So we have x plus 1 squared is equal to 12. So if you want to think of this as taking the square root of both sides, that tells me that x plus 1 is equal to plus or minus the square root of 12. But here there is no escape. You have to simplify your radicals. So let's simplify this radical before I do anything else. Well, 12 is 4 times 3. So that's supposed to be, I'll use parentheses there, 4 times 3. So I'm still not doing anything to the left-hand side. So the square root of 4 is 2, so it escapes from underneath the sign, but the 3 has to remain behind. Now I'm solving for x, so I have to move the plus 1 over to the end. So x, and it becomes minus, is equal to plus or minus 2 on the square root of 3 minus 1. So I want you to realize that explicitly this means x is equal to taking the top, the plus, the positive root, 2 on the square root of 3 minus 1, or x is equal to taking the bottom sign, it's called the negative root, 2 times the square root of 3 minus 1. So those are our two solutions. We have two solutions here. Okay, so we're going to look at some perfect square. The next goal we're going to do is learn how to complete the square. It seems like it's worse than you think it is, but it's actually really easy to do. And interestingly enough, I mean, you all, I'm sure, are not aware of this. There have been several videos out ever since December of 2019 saying, oh, there's a better way to do this. So one of the reasons we're introducing how to complete the square is it's used to derive what's known as the quadratic formula. And someone just published a thing saying, oh, there's a better way to derive the quadratic formula. And I've looked at it, and I've looked at it. There's this kid that does quarantine math. He started out his video with it. And it's another way to derive it. Whether it's easy or not, I don't know. But the problem with it is we miss something really important that we get by completing the square. So you're not going to be required to know how to complete the square to derive the quadratic equation. But you will be required to know how to complete a square and use that to solve a quadratic equation. So let's look at this little bit of pattern. So we have x squared plus 8x plus 16. In factored form, it's x plus 4 squared. That's interesting. Notice that 16 is a perfect square, and 4 is 1/2 of 8. And 16 is 1/2 of 8 squared. Okay. So x squared minus 6x plus 9 is x minus 3 squared. So 9 is a perfect square. Minus 3 is minus 6 divided by 2. And minus 3 squared gets me 9. The final one, x squared plus 3x plus 9/4 is factored as x plus 3/2 squared. 3/2 is 3 divided by 2. And 3/2 squared is 9/4. So that's the pattern. Another way to see this is, I'm going to kind of work you through this, and I'm going to give you a visual example, is if we have a quadratic equation, x squared plus 2x minus 1 is equal to 4. The first thing we want to do is we want to move this term, the constant term, which happens to be minus 4 in this case, and we want to move it to the other side. I'm going to pause for just a second. So we have x squared plus 2 times x is equal to some number. There's a nice visualization of this. So, and you'll understand why it's called completing the square. So we have a simple expression like x squared plus bx. And x is found twice in the expression. So this is kind of like the way the Greeks saw things. So Greeks saw numbers as area. So if we look at a square of side length x, its area is x times x, which is x squared. If we look at this rectangle right here, clearly this side right here, this long side, has length x because it's the same length as this. And if we say the shorter side is b, then the area of this is b times x. So this area-wise represents x squared plus bx. Now if I take bx and I split it right down the middle, right in half, so I take b halves and b halves, notice that the x length is still there, so I'm just taking the b and I'm splitting it down. So what I've done is I've taken b halves, this term right here, b halves times x, and I've just split it down and rearranged it. And the result is almost a square. This is x plus b halves, x plus b halves. That's the length here. So of course this is x plus b halves squared. And what I need to do to complete the square is to add b half squared. So the length of this little here and this little here is b halves, so the area is b halves square. So that's how we get the name completing the square. So let's just go back here and let's just actually, this is step by step, but I'm going to show you an actual example. I think it's just better that I use, well, I can use the example I had right there. Let me write it down. X squared plus 2x minus 4. So we have the equation x squared plus 2x minus 4 is equal to 0. So this is an equation, so the general form of a quadratic equation is ax squared plus bx plus c is equal to 0. And before the end of this lecture, you're going to have to identify the values of a, b, and c. The value of a is the coefficient on the x squared term. The value of b is the coefficient on the x term. And c is the constant term. So for right now, I'm just going to write that general formula right underneath what I have. And that allows me to identify a is equal to 1, because this has an unspoken coefficient of 1, an unwritten coefficient of 1. B is equal to 2. And C is equal to minus 4. As it turns out, of those three values right there, the only one we need to complete the square is the b value. So what we do is I take my original, x squared plus 2x minus 4, and I concentrate on the x squared plus 2x part, just like what we saw in that square representation I just showed you. So I'm going to take the minus 4 term, and I'm going to move it to the other side, and it becomes plus 4. And I'm going to do something here. I'm going to erase this. Not that I've written anything wrong. I want to give myself some room. So I'm going to put my equal sign on down here, and I'm going to put my 4 here. So over here on the side, I'm going to note my b value. My b value is equal to 2. So then I'm going to compute two more values. B divided by 2, which is 2 divided by 2, which is equal to 1. And b divided by 2 squared. So you take the result of this last result here, and it's 1 squared. And that's just equal to 1. And what I do is I add that value to each side. So that gives me x squared plus 2x plus 1 is equal to 5. Now here the next step is to write the factorization. And the point here is you don't have to do any of our table method. Indeed, our table method would not help you. Our table method of factorizing polynomials works only when the coefficients of the factorization are whole numbers, integers plus integers, whole numbers plus or minus negative whole numbers, plus or minus positive whole numbers, sorry. So literally what I'm going to do is I'm going to write the factorization. I don't have to do any work. I have all of the information for that factorization. I turned all of this process, remember in the video we had a square with a little bitty hunk in the end, and when I added b halves squared to it, I was completing the square, so the end result was a full square. So the end result is b halves squared, and we made that into a complete square. So what we add here is b halves. So that's what we add, is b halves times b halves. So I go up here and I have my b halves, which is 2 divided by 2, which is equal to 1. So I add 1 in there. So we have x plus 1 squared is equal to 5. And now we're going to solve it. That's the whole point. So we're going to take the square root of both sides. That gives me x plus 1 is equal to plus or minus the square root of 5. So that means x is equal to plus or minus the square root of 5 minus 1. And just to remind you, there's two solutions here. One solution is x is equal to the positive root of 5 minus 1, and the other is equal to the negative square root of 5 minus 1. So that's how we do that particular problem. Let's do a few more of these. So here we have a polynomial in M for whatever it's worth. They wanted it to be in M. So we're going to factor this. Not factor, we're going to solve the equation by completing the square. It's prime, so it doesn't factor. I'm assuming it's prime. I actually haven't verified it. So the variable is M. If the variable M bothers you, just change it to x. Remember, these are dummy variables. So it's in the form ax squared plus bx plus c. But of course, our variable now is not x, but m. So we write it this way. And what we want to do for completing the square, we want to identify our b value. And our b value is the coefficient of the degree 1 term together with its sign. The coefficient always includes its sign. So b is equal to 7, so I calculate b halves. So that's equal to minus 7 divided by 2, and that's going to be important. And then I calculate b halves squared. That's always going to be a positive number. So minus 7 halves squared is 49 fourths. So I'm going to use that. So our first step, after I've got all of this information over here, is I take the constant term and I move it across the equation, the equal sign rather, and I have this. And now what I do is I add the value of b halves squared, it's always going to be a positive value, to both sides. Now of course we're going to want to simplify the right hand side eventually. But now once I've done that, I'm ready to write the left hand side as a perfect square. So that's supposed to be m squared there, sorry. So that's m plus b halves. So I come over here and I grab the value of b halves, which is minus 7 halves squared. And that's equal to 1 plus 49 over 4, which is, I'm going to write 1 is 4 over 4. And that's my common denominator, plus 49. So in my very next case, I have m minus 7 halves squared is equal to 4 plus 49 is 53 fourths. So let me give me some more room up here. So now I take the square root of both sides. So that gives me, I use the square root property. M minus 7 halves is equal to the square root of 53 over 4. Sorry, I didn't leave enough room to write my plus or minus. Always remember to write your plus or minus. Plus or minus. So that means m minus 7 halves is equal to plus or minus the square root of 53 over the square root of 4, which is just 2. So here I'm almost done. Let's go ahead and write out my final answer. So I'm solving for m, so I'm going to move the minus 7 halves. So m is equal to plus or minus the square root of 53 over 2 plus 7 halves. So that means m has two values. It's equal to the square root of 52 plus 7 divided by 2, if you want to put both of those over the common denominator, or you can write it like the square root of 57 halves plus 7 halves, it doesn't matter. Or m is equal to the square root of 52, which is the minus root, plus 7 over 2. So those are my two answers. So I'm anticipating a few of you wondering how I got from here to here. So let's go ahead and work that out. I'm just going to leave the plus or minus off. Let's look at, this is just a review. The square root of 53 over 4 using the quotient rule is the same as the square root of 53 divided by the square root of 4, which is equal to the square root of 53 over 2. And that's how I got my plus or minus square root of 53 over 2. I think I have one other one I want to do. Now in your notes, if you're following along, our next example is example 5. Now I'm not going to do this one. We could. It's not too difficult. I just want to notice that if we're going to solve 2x squared minus 8x plus 3 is equal to 0, that you have to make the polynomial monic. That means the leading coefficient has to be 1. So what you do is you just divide through everything by 2. And that will give you x squared minus 8x over 2 plus 3 halves is equal to 0. And you can go on. As a matter of fact, let's go ahead and just work out this one. it's not so bad. Wrong button. So we want to, it's really not so bad. So if you go back and you look at our method of completing the square required that the leading coefficient be 1. And here we don't have a leading coefficient be 1, and I'm assuming, yeah, this is definitely a prime. There's no way I can solve this by factoring. But this is an equation, so I can multiply both sides by 1/2, or what is equivalent, divide both sides by 2. And when I do that, 2x squared divided by 2 leaves me x squared, minus 8x divided by 2. Well, minus 8 divided by 2 is minus 4x, plus 3/2 is equal to 0. And that is the equation that we're going to look at, is just this one. So again, over here on the side, my b term is equal to minus 4. So b halves is equal to minus 4 divided by 2, which is equal to minus 2. And then finally, b halves squared is equal to minus 2 squared, which is 4. That's always going to be a positive. So what we do over here is my next step, I take my constant term and I move it to the other side. So 3/2 becomes minus 3/2. And then what do is I add the same number, my b halves squared value, to both sides. Now once I've done that, I have a perfect square here. So this is x, and I add my b half term, which is minus 2 squared. And I'm going to write minus 3/2. I'm going to multiply minus 3/2 by 2 over 2, which is the same as 1. So I get minus 6 over 4. It's minus 6 over, I didn't want to do that. My least common denominator is 2. I wanted to do that with the 2. I don't have 1/4 over there, I have 4. I was thinking I had 1/4. I don't know why I was thinking that, but I was. So let's put on the brakes. So my least common denominator is 2. So instead of writing minus 3/2, I could have proceeded like I was going and then just changed 4. I want to write 4 with the denominator over 2, but 8 divided by 2 is 4. So now it's just a process of simplification. So again, we have x minus 2 squared, and 8 minus 3 is 5/2. So now I take the square root of both sides. So that gives me x minus 2 is equal to plus or minus the square root of 5/2. So x is equal to plus or minus the square root of 5/2 plus 2. I'm going to tell you right now, I'm not thinking that my math lab is going to be happy with that as an answer. And the reason being is, let's work on this term right here. Let's ignore the plus or minus. The square root of 5/2, using the quotient rule, is the same as the square root of 5 divided by the square root of 2. And I have a feeling my math lab, if this is on your homework, is going to ding you. And it'll say, I want that denominator rationalized. Well, we can do that. We just multiply the numerator and the denominator by the square root of 2. So the square root of 2 times the square root of 2 is 2. Now I use the fact that these have the same indices. That's just equal to the square root of 5 times 2, which is 10. So that means x is equal to plus or minus the square root of 10 over 2 plus 2. And again, just to reiterate, that means x is equal to the square root of 10 over 2 plus 2, or x is equal to minus the square root of 10 divided by 2 plus 2. Okay, the next thing I have in mind is we're skipping all the way to 8.2 now. And that means I have to bring up another document. And you all have heard of this. You may have actually used this in high school. It's the quadratic equation. I'm not going to go through the derivation. It's here for you if you want to see it. All we're going to do is look at the results. So suppose ax squared plus bx plus c is equal to 0. I add the additional condition that a is greater than 0. So if a actually turned out to be less than 0, you just multiply both sides by minus 1, and a would become greater than 0, and the equality would be the same. And really, I literally just complete the square using symbols. I divide everything through by a, just like we have to do, because we can only complete the square when the leading coefficient is 1, and I complete the square. And when I do so, I literally get the following value for x. And this is the quadratic equation, or sometimes called the quadratic formula. And the quadratic formula can be used for any quadratic equation. So this should be memorized if you don't already have it memorized. X is equal to minus b plus or minus the square root of b squared minus 4ac. All of this is under the radical divided by 2a. So we're going to use the quadratic equation to do a few formulas. So, and in your test on this, there will only be a few questions. You will have to solve it the way I indicate. If I tell you it needs to be solved by completing the square, you have to solve it by completing the square. If I say solve it any way you want, you can solve it any way you want. If I tell you you have to solve it using the quadratic equation, you have to solve it using the quadratic equation. So to solve the quadratic equation, we have to find the values of a, b, and c. Because if you remember on the derivation, I start out the whole thing saying let ax squared plus bx plus c equals 0, where a is greater than 0. So my a term is greater than 0, and it's 3. It's almost always given to you greater than 0. My b term is equal to 16, and my c term is equal to 5. So when we were completing the square, all we cared about was the b term, but now literally we care about everything. So now I want to use the quadratic formula. The quadratic formula says x is equal to minus b plus or minus the square root of b squared minus 4 times ac. All of it is over 2a. So literally all I'm going to do is fill in values of the formula. So here's filling in the values. X is equal to minus b. The minus is part of the formula. And my b is 16. If my b were minus 16, that minus has to come along with the b. It doesn't get to use the existing minus already there. Plus or minus the square root of b squared, which is 16, that's my base, squared, minus 4, the minus is inherent, times a, which is 3, times c, which is 5. That's all under the radical. And then the entire thing is over 2 times 16, which is the value of a. Sorry, not 2 times 16. 2 times 3 is the value of a. Let's get this right. So now literally it's just a matter of simplification. And that's all we're going to be doing. So the first thing what I normally do is I simplify two things in the second step. I find out what number is underneath the radical. So 16 squared is 256, and 4 times 5 is 20, times 3 is 60, so we're subtracting 60 from it. And that's equal to 196. So it's the square root of 196. And I don't need all of that. And then it's all over 2 times 3, which is 6. So the square root of 196. It's okay that you use your calculators in the following way. Instead of using the square root button, just try to find it out. 11 times 11. That's 121, so I need to be more than that. So let's try 13 times 13. That's 169. Well, 14 times 14. That's 196. So that gives x is equal to minus 16 plus or minus the square root of 196 is 14 over 6. So I have two solutions here. We have to simplify some more. Minus 16 plus 14 is minus 2 over 6. So that's the same as minus 1/3. There's one answer. So let's take the other root. Let's do minus 16 minus 14. So minus 16 minus 14 is minus 30 divided by 6, which is equal to minus 5. So those are our two answers to that equation. Let's do another example. Again, using the quadratic equation to solve 2x squared minus 4x plus 3. See how nice it is. Now, a lot of students prefer the quadratic equation. We prefer that you factor it if it's factorable. But I understand if you're on a test, trying to factor that, you don't know if it's prime or not. And if you try to factor it, it's going to kill some precious time. So why bother? Just immediately whip out the quadratic equation. So instead of you having to make that decision, I make it for you. So I will tell you either complete the square or use, for this particular test, the quadratic equation. Factoring won't be one of the options. So again, we got to identify our values of ax squared plus bx plus c is equal to 0. So my A is equal to the coefficient on my leading term. B is equal to the coefficient on my degree 1 term. And C is equal to my constant term. So I'm ready to solve it using the quadratic equation. X is equal to minus B plus or minus the square root of B squared minus 4 times A times C. All of that is over 2A. So now I'm just going to replace minus B. So minus is inherent. B has to bring that negative along with it. Then I do minus B, but it's going to be squared, so it'll become positive. Minus 4 times A, which has a value of 2, and C has a value of minus 3. All of this is going to be over 2 times A. So again, now it's literally just simplification. Starting down here, minus a minus 4 is 4. Now I like to figure out what's underneath the radical. 4 squared is 16. Minus 4 times 2 is 8. Sorry, minus 4 times 2 is minus 8. And minus 8 times minus 3 is plus 24. So 24 plus 16 is equal to 40. So that's under the square root of 40. And of course we want to write that as 4 times 10. All over 2 times 2, which is 4. So the next thing I'm going to do, since 4 is equal to 2 squared, the square root of 4 is 2. So 4 is a perfect square. So it can escape from underneath the radical. And it comes out as a multiple of the square root. We just have the square root of 10 that stays underneath, under 4. And that's a perfectly fine answer. There is, however, a way you can simplify this more. You can either write it as 4 divided by 4 plus 2 on the square root of 10 over 4, which is equal to 1 plus the square root of 10 over 2, or 4 over 4 minus 2 on the square root of 10 over 4, which again is equal to 1 minus 2 divided by 4 is 1/2, the square root of 10 over 2. Both of these are very acceptable answers. And there's 2 different answers. And we only have one last thing that we're going to look at. And it's a really important part of the analysis using the discriminant. So when we look at the quadratic equation, again, sometimes it's called the quadratic formula, doesn't matter, minus b plus or minus the square root. And what I'm going to write in green is called the discriminant, b squared minus 4 times a times c. All of that's going to be over 2 times a. Maybe I'll make that yellow too. So I want to highlight the discriminant. So the discriminant is the value of b squared minus 4 times a, so c. So this is actually a value. So the discriminant is given to you for a particular quadratic equation. So notice that the discriminant is always under the radical. So if the discriminant of b squared minus 4ac is greater than or equal to 0, then x is a real number. Or, since many times we have two solutions, numbers. On the other hand, if b squared minus 4ac is less than 0, then you're taking the square root of a negative number, and the solution is a complex number with a non-zero imaginary part. In other words, what this is telling you is bi will appear in the solution. And here I probably should have not used b. I'm taking it back because the b I used there is not related to the b up here, and that may be confusing. So some multiple m times I, some multiple m times I, m is a real number, will appear in the solution. That's all of that. X is a complex number with non-zero imaginary part. This is all that verbiage means, is that m times I will appear in the solution where m is not equal to 0. And that's it. There's quite a bit of criteria and other things that you can say, but these are the only two criteria that I'm going to hold you accountable for. 1, the case where b squared minus 4ac is greater than 0. And 2, b squared minus 4ac is less than 0. And it encompasses all of this. So that's it for Chapter 8, and that's it for the new material you're going to be learning in intermediate algebra.